All right. Hello, everybody. Welcome to this little podcast. My name is Tom Froese. I'm here in the studio at OIST, the Okinawa Institute for Science and Technology, Graduate University in Okinawa, Japan. And the opportunity to have this little podcast comes from Connor, who's here with us, reaching out and being interested in the work we're doing on agency and consciousness because he will be writing some things on this topic. And so we thought it would be a great idea that this conversation will be recorded so that everybody can have a listen in to see our work in progress, so to speak. So let me just hand it over to you, Connor, so you can also say a few
Mhm.
words.
Yeah. Thanks for having me, Tom. Um, my name's Connor. I'm a freelance science journalist from New Zealand. I'm currently based in Bangkok. And yeah, I write for a number of different kind of popular science publications on a number of different topics. But yeah, these questions of mind, agency, consciousness have been really interesting me lately. So
Mhm.
I came across your paper, Tom. So I thought it would be fun to talk about these ideas a little bit in a little bit more depth. Yeah. So thanks for having me.
No, for sure. I think these are really exciting times for probing more deeply into those two concepts. Especially with all the AI, revolution all around us, and talk about agentic AI and our machines' consciousness and so on. These debates are unfolding at lightning speed, and so I think it's the right time, to revisit our understanding of these concepts and really, push forward our thinking in those areas because now there's real practical concerns that just goes beyond like the mere philosophical interest in these questions, with respect to the technological developments that are happening.
Totally. And I think that, maybe these conventional ideas we've had about who and what possesses a mind and consciousness is kind of uh there's been somewhat of maybe a paradigm shift where we're considering things much simpler things
Hmm.
uh as maybe possessing minds, levels of intelligence, agency, things like plants or single-celled organisms, or
Hmm.
maybe even systems that we wouldn't even consider to be living.
Hmm.
Um, so yeah, it's an exciting time, and like you say, in the context, of artificially intelligent systems as well. So yeah.
Right, right. So we're going, beyond the non-human in a
Yes.
number of different ways, basically, right? So non-human in the sense of still living. But then, those boundaries get fuzzy once you get into, distributed living systems, that where we don't have a well-defined individual anymore. And then, pushing back to the origins of life, exactly where do you want to make that cut? What properties do you need? And then, of course, pushing out into the complexity that's coming out of our artificially created systems, which rivals in complexity now living systems. And even though the physical realization is different, the question is, what are exactly like the most important organizational or even bodily principles, and what so we used to have a sample of one, maybe like if you really go far, like let's say with someone like Descartes, who would say that only humans are true agents, rational agents, and only humans have consciousness and a soul, he would say, I guess. And everything else are just machines, whether they're living or non-living. So that, it's just a sample of one, and everything else was in one big category. And now the sample size has been increasing, right? So we might as well still say, living systems, maybe that's a sample of one because we've not really encountered life from other worlds. So, that's limiting us in some way of saying what's unique or essential and necessary and what's contingent about life the way we encounter it on this planet. Um, but then there's this very exciting possibility to say, what if we consider the current, say, large language models and all their, super unexpectedly impressive capacities as maybe another example of intelligence. And so maybe our sample just, increased to two. But it came from a very unexpected place, at least for me and for many other people who thought that there was maybe, a little bit more, biology needed for these kinds of capacities. So yeah. So what's on your mind, Conor? So what is like the, what's keeping you up at night about these developments?
Um, well, one thing that I've been working on recently is this concept of noise and like the relationships between, I guess, living systems and noise has, it seems like, has often been kind of cast as like living systems want things to be neat and predictable so that we can
Hmm.
kind of carry out our functions, and noise gets in the way. And so we
Hmm.
have like error correction
Hmm.
enzymes that make sure our DNA is reliably encoded, and we have an immune system to
Hmm.
fight off invaders, and we build perceptual models of the world to
Hmm.
predict how things will unfold. And so noise has often been maybe historically thought of as this nuisance
Hmm.
that life has to overcome. Um, but then it kind of seems like there is also this emerging alternate narrative where um, living systems actually regulate and sort of harness, if you will, the noisiness of their components to
Hmm.
generate solutions to
Hmm.
to these problems that they face.
Right.
Um, and then so that that kind of story, when I came across your paper on eruptions,
Hmm.
felt like it kind of fit into this narrative.
Yeah, for sure.
If that,
Yeah, yeah. I'm
yeah,
I'm happy to hear that you're, a fellow traveler along this path.
sure.
My intuition is that noise is going to make a huge comeback. It's early
Hmm.
days, but maybe if you think of the 80s, with chaos theory, getting everybody super excited, and and that to some extent led into complexity theory and things like that. But what a lot of people don't, think about is that chaos can be totally deterministic still in a way, right? So, yeah, it's practically surprising to us, but it's not really intrinsically surprising, in the sense that if
Hmm.
we were in another possible world where we could reset the conditions to be the same ones, and the rules are the same, the system would display identical behavior. Okay, and then there are practical limitations that you can't do that because at some point precision will kick in and say there will be these minuscule differences, and given that the system is sensitive to different, these very small differences in initial conditions, or macroscopic behavior will be different at some point. Um, but this is a more like a practical, problem. It's not something that's intrinsic to the system. And
Hmm.
noise, uh, in a genuine sense, is a different kind of beast. It's something which, to some extent, sits outside of the what we can make sense of. It's that which is left over, when we've done the best work we can and trying to explain all the changes that are happening in whatever it is that we're observing. And for that reason, it has been considered a kind of nuisance, right? Because it shows our own limitations in a way, right? So if you, especially if you're buying into a worldview where, maybe Newtonian or Einsteinian, worldview where everything should be deterministic and everything's already predetermined and we're just a trajectory moving through a block universe, then our ability, or our lack of ability to give a complete story, then can only be because of the limitations of our local point of view, basically. We could have done better,
Hmm.
but we didn't.
Mm.
And and that's why quantum physics was so challenging because the noise wouldn't go away in a way, the stochasticity wouldn't go away. But still, even today, there are many people who think that the right way of dealing with quantum physics is to find a way to get rid of the noise and to kind of like cover a completely deterministic picture that such that both the quantum and the classical are deterministic and their interaction is also deterministic and but to do that, to just give one example, you have to make, just insane assumptions, right? So considering the many worlds hypothesis, right? So if you wanted to keep quantum physics deterministic and, evolving in a unitary fashion, then the way to explain why it appears to us that there are these, inexplicable jumps and things like that is to assume that that's just one possibility out of, an infinite other possibility where all the other things were also happening at the same time. And so in order to explain, in order to get rid of this stochasticity, you basically just have to assume now that there's an infinity of other possible worlds. And like why not just assume that there's stochasticity instead, right?
Mm.
I mean,
Mm.
the cost is huge, to try to
Yes,
get rid of it.
yes, yeah.
And so, but yeah, it's because, it felt like a limitations. I think it feels for many people like something that should be gotten rid of. And the point that you're making about biology actually to some extent resourcing noise, that's to some extent the noise is part of being able to adapt. I think that's the kind of key shift that we have to undergo. And then once you are in that game and saying, well, actually, yeah, noise can loosen up state space, it can shift things around. It's actually something that living systems take advantage of, and so on. You mentioned eruption theory, and eruption theory goes one step further and then says, what if this noise is actually something that is intrinsically controlled by the living systems? It's not just external, contingent, but it's actively generated by living systems. And then the theory has, some in principle reasons for arguing why it would be the case that life and mind at work in the material physiology of the body would show up what we would consider noise.
Mhm. Yeah, yeah. A couple of thoughts. Like what you're saying is interesting because it's almost like it's a matter of our ignorance,
Right.
and to a large extent. And like, yes, but sort of, it's interesting, like talking to people about noise or the sources of noise at varying scales of reality, like
Mm-hmm.
um, in the sort of quantum realm, like I've heard where that's the sort of natural stochasticity of particles behaving in probabilistic
Mm-hmm.
ways, like that's almost the only kind of example of non like true noise in a
Mm-hmm.
way, like
Exactly.
with non-causal foundations.
Mm-hmm.
And then as you sort of start um, going up scales and you're getting into the world of statistical mechanics
Mm-hmm.
and you're dealing with large volumes of matter and
Mm-hmm.
talking about systems like brains or cells,
Mm-hmm.
then noise turns into something of a matter of us having limited information about the state of the
Right.
system and trying to make predictions about
Right.
what it will, the future states of the system.
Yeah, I think that this debate happened in physics too in the very beginning, right? So you have Heisenberg with his Bohr, where Heisenberg's uncertainty principle was initially thought of more as a kind of epistemic limitation. It's us perturbing the system, and because we have to intervene in the system to measure it, there will always be, some interference term and so on. And then Bohr says, no, this is actually intrinsic, to nature. It's not because of us, but it's something fundamental about, how nature works that it shows up this way to us. And so they already had this, is it epistemology? Is it ontology? That kind of debate there. And I think it's still going on. Like I said, there's still this argument about what's the right way of thinking. But at least there are some people who genuinely defend the view that there is noise there. Um, and you're right that if you move away from that, it becomes kind of derivative in a way. If you're interested to look into this more, I recommend having a look at a paper by Carlos Rovelli, who writes on agency, and his point is precisely the one that you're making, that um, our behavior is unpredictable in a way, right? And that's also why a little bit like I guess quantum physics, psychology has a lot of similarity in the sense that time matters, interaction matters. It's a probabilistic science. We don't usually try to create deterministic models of individual human behavior. We can only do that over the average in statistics and so on. And he says that the kind of like the reason for the why agency has this unpredictable aspect is because that sometimes the separation of the scales of nature breaks down. So most of the time you have, the different scales being like effectively isolated from each other so that, Newton didn't have to care about the quantum, for example, right? And if you're looking at living bodies and their behaviors, you don't have to worry about what the little atoms are doing and things like that. But he says that basically sometimes these separation between scales breaks down, and you've got kind of some kind of quantum uncertainty bubbling up through the scales, which then expresses itself as unexpected changes in large scale system behavior. And okay, yeah, that's one way of trying to explain things. But if you do it that way, you don't really gain any kind of explanatory insight into agency. Um, in a way, it's an attempt of explaining agency away, is how I would see it, right? So this is going to be important, I think, for listeners, but also for your essay, maybe to work out is that, if it was just noise, like standard noise, what use would it do, right? And would that
Mm,
give us any freedom? Because like, who wants their bodies to be controlled by just, quantum fluctuations rather than by their intentions, right? So maybe from a like distant view, if you measured the uncertainty of behavior, you couldn't tell the difference. But ideally, we want to have a story to tell of how do we go from something that is on your mind, you want to do something, you have a goal, to your behavior aligning with that goal. And that's the problem of mental causation, right? And
mhm.
the idea is that noise will play a role in that account, but it's for different reason than just uh, coincidental, burst of quantum fluctuations,
Yeah,
bubbling up.
yes, yeah. Yeah, so maybe then it would be helpful if you talk about some of the like sort of first principle
Hmm.
uh, or axiomatic principles that you have
Hmm.
um, for eruption theory,
Hmm.
um, and then we can kind of go on from there and
Hmm.
see how noise maybe fits into this.
Great.
That
Yeah, let's
that
do it.
works.
So
Yeah.
the way I think about eruption theory is that I want to get into terms that are so simple in their little steps that we can take, that for each step, most people would say, "Yeah, I agree with that." But when we have them all lined up, we'll realize that we're going to be in a different place than where we started. So that I'm gonna try that on you, Connor. So let's see.
Mm.
So the starting point is to be realistic about that minds matter, that life matters, that our intentions matter, our experiences matter, right? So realism about the mind, is the first step. So there are many reasons for this, for starting with this point, but one is that if we don't accept this position, then everything else basically goes out the window. We can't even really have an argument anymore. I mean, I want to convince you that eruption theory is the right way of thinking about it, for reasons, and because I think it fits the facts and all this, standards of, what a good theory should do. Um, but if we are saying that mind makes no difference, uh, then then what are we doing here, right? So basically, we're already implicitly assuming by having a conversation, by doing science, by writing papers and doing experiments, that mind makes a difference. It's the bedrock for all of our activity. And if our theories lead us to a point where we suddenly get, are forced to say, hang on a second, if we follow this line of thought, it means that our minds cannot make a difference. It's epiphenomenal. It's just weakly emergent or something. I think what that shows is that we've taken a wrong step somewhere. That basically means that that's a dead end. We should start again, rather than then insisting that this is the right way of thinking about the mind. So I think we've given too much airtime to theories that, they sound very dramatic, right? You're
Hmm.
nothing but a pack of neurons, or like, your brain controls everything that you do and all this kind of thing, right? But it's very unhealthy. Apart from its sensationalist value, it's very unhealthy. And it just doesn't make any sense. We want science to be recognized and valued because of the reasons, because of we have good standards of evidence, because we know how to design experiments, because we know the statistics, right? And these are all normative claims. Okay, it's about the value of being accurate. It's about the value of looking for what is correct versus wrong, and we want correctness and accuracy in which are not just natural things, right? These are standards that we set. We want those to make a difference in our practices. Okay, so you know, I think for most people, like in the world, this is not even a question, right? So they just assume that, of course, somehow what I want and what I believe and what I feel makes a difference to how my body moves and how my behavior unfolds and everything. It's just, us cognitive scientists and philosophers, and especially maybe some neuroscientists who say, well, maybe we're all wrong about that. But, if they actually really believe that, they would be basically, exiting from the general discourse of science. We've
Hmm.
lost them. They're no longer communicating. They're just like, material events happening in their mouth. They're not actually doing things for reasons, right? So that's part number one. I just want to maybe just briefly stop there. So this is like, the mind,
Yep.
matters basically. That's
Yeah.
axiom number one.
Yeah. Yeah. I think like, yeah, that's like the intuitive position that we all sort of take in how we interact with the world. But yeah, like you say, there are people who have like would it be fair to say like Dan Dennett was kind of a
Hmm.
advocate of this like epiphenomenalism or sort of illusionist position or
Yeah, it's a bit
um
complicated. I think he was trying to
yeah,
find a middle way, right? So he didn't
yeah,
like the original classical cognitive science of Fodor and so on, where
yeah.
the only way in which we could understand how the mind works was like folk psychology, belief desire psychology, and then, somehow
Hmm.
that had to be, implemented in the brain, which just there's some kind of incompatibility. You don't find belief desires in the brain. We'll get to that in a moment.
Hmm.
But
Hmm.
and then you had a kind of really strong negative reaction against that kind of folk psychology by people like Churchland and so on, who argued for the eliminativism, saying that,
Hmm.
in the future, you know, our best explanations of why people do the things they do will just appeal to, brain states, and
Yeah.
not anymore to their mental states. And
Mm.
I think then it
I
tried to kind of like, have it both ways and say, no, it's still useful.
yes.
We'll be allowed to talk about mental states and how they have consequences, but we're not forced to then assume that you have these same states, inside your brain.
Yeah.
So there can be some kind of like, disconnect between these levels.
Yeah.
Yeah.
I guess it's also interesting from kind of like an evolutionary perspective of like why would evolution sort of grant us conscious experience
Hmm.
at all if it makes no material difference to our
Yeah.
existing
Perfect. Yeah. 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 Yeah.
in the world?
Yeah. Yeah.
Or
Great. Yeah.
there's that is it the philosophical zombie thing that kind of Chalmers talks about as well, like
Yeah.
in principle if we were just physical exact physical replicas of
Hmm.
ourselves but lacked consciousness, would there be any difference in
Hmm.
how we interacted with the world? And I think our intuition is that yes, like our minds, our feelings, our intentions drive
Hmm.
us to interact with the world in ways that serve our serve our adaptive needs or something like that. Yeah.
Right. There's a couple of things here. So we can talk about the functions of consciousness, but then you easily walk into functionless territory, which is
Hmm.
kind of like what inspires the philosophical zombie thought experiment. But what you
Hmm.
initially said, I forgot to mention, and so I'm glad you brought it up, which is to say that normally any phenomenon that we can distinguish should have some signature, like it should have some interaction with something else, some energetic cost, it should. So the idea that there's this thing which we call, our mental states, that we can reflect on our, desires and thought processes, and that we have all this rich qualitative experience, but actually, that could potentially not exist and not make any difference to anything else in the world. Seems crazy, right? That's not how we usually think about natural phenomena. Like every natural phenomena should have some implications for the things which is connected. Otherwise, it doesn't exist, right? And so, and this gets, into this again, we have a realism. So a realism means that the way in which we want to think about these phenomena should make a difference for something else. And so it goes back to the ancient Greeks, where we think about, how existence somehow was very closely tied to making a difference, and so one thing I keep complaining about, and maybe you can go back to it, is that most current theories of agency and consciousness don't even meet this minimum requirement, as far as I can tell. We can debate that a little bit, but this question about could they distinguish between the presence and absence of consciousness? Most can. And that's why the philosophical zombie thought experiment is so powerful because, you know, according to most theories, it is actually conceivable that there could be no consciousness and everything else would be the same, right?
Hmm.
But that I mean that's scandalous. I think we really need to try to do better than that. And so there's two ways of going. So it's good that you brought this up. There's two ways of going about this first axiom. One is a kind of introspective way, or a kind of social way in saying that we need this. We come from this. And if you take it away, you're basically taking away the whole argument. The possibility of having a debate, even. But that's maybe too meta for many scientists, right? They don't care so much about the extra scientific implications of what they're saying or the philosophical implications. But the point that you're raising is much more closer to a scientific concern, which just says that, if this is a phenomenon, is a concrete phenomenon, then it cannot be the case that it makes no difference to anything else. And so that's another way of saying mind matters. And so we can just take that as an axiom and say, maybe we don't understand yet how it matters, but if it's a real phenomenon, it must matter somehow. Yeah, exactly.
Cool.
Good. All right. So axiom number two then, and we touched briefly on it in response to your question about Dennett, because I brought in a Churchland, and what shocked people, I guess, with the neuroscience, the neuroscience revolution, when we were able to actually look at what's happening in detail in people's brains while they were engaging in a task or narrating or introspecting and things like that, is the complete absence, in a way, of the entities that populate folk psychology. We cannot measure any thoughts or ideas or feelings or having intentions or experiences and so on. So if we, whatever instruments we use to measure the brain, externally, intracranially, at whatever scale, we just find nature. We find the usual physical quantities that we would also find in the rest of the world. And there are some interesting differences. We're slightly differently organized. Maybe we use a special subset of biomolecules rather than the full set. But then again, we're synthesizing much more other molecules that wouldn't exist without us, and so on. So there's interesting things there. But I would think that, if you were let's say, alien computer that knows nothing about, the mental level, the conscious level, and analyzes our body, the question would be, a little bit like the philosophical zombie thought experiment. The question would be, would it suddenly say, oh yeah, these are thinking beings? These beings have consciousness and things like that, just by looking at our material bodily processes alone. And at least, from first sight, I think everybody agrees that, there's nothing there, and that's pretty shocking in some ways. So if you walk, into a neuroscience lab, and you look at what they're doing in order to understand how the brain works and how it connects to behavior, in a way, they don't really have any use for mental language. Okay, so maybe they do it as a heuristic and say, well, the rat had a goal, but that's not the explanation, really. The explanation will be, something happened at the sensors that triggered some activity in the brain, that triggered some motor activity, that activated the muscles, and then there's the behavior and so on. And that explanation, if you break it down, it seems like it could be told in purely objective terms in quantities that are well known to physics. And there's nothing mysterious, really, at least at first sight. And so the second axiom wants to really, like, let us sit with the tension that comes from this and accept there is nothing there. Okay, so when we adopt this objective point of view on living-minded beings, for even if we have reasons to believe that they are conscious agents, we do not get anything different happening in our measurements when we go in and measure things. And that's, yeah, people resist that. Just like they resist the first axiom in some ways, they also resist this one. And one way in which you find resistance is representationalism. So you will say something like, this neural activity encodes something. This pattern of activity represents something. And so suddenly you have language which is originally mental. Okay, we can represent, a dog by the word dog, for example. Okay, that's a representational relationship. We can do that. And suddenly that gets kind of like interjected into our explanations of how the brain works. And we say, well, this neuron represents something outside of the body or something like that, right? But it's clear that that is just a kind of, an extra layer to make it more palpable for us. Because if you look at what the actual explanation is, there is no such thing as a representation anywhere in the dynamics of the neurophysiology, right? It's electrical potential and chemical gradients and this kind of stuff. So it's not like at some point you say, okay, and there's the representation, and that's why this voltage is changing now. It doesn't have that kind of physical integration into the rest of the narrative. And that's difficult to hold because it's very stark contrast with how we think of ourselves. And that's why most people, I think, try to find a middle way and still try to somehow talk about representations, even if we don't really directly have any evidence for them inside the brain. But I would say let's not introduce things where they don't belong, basically, and just stick with what we have. And that is, there's just physics, and we don't see the mind showing up as such.
Yeah, I totally agree, and that seems like that issue that David Chalmers brings up, and like that's kind of the hard problem,
Exactly.
right? In
Yeah.
a nutshell. And
Yeah.
but I guess like when you talk to like when I've heard sort of neuroscientists talk about like trying to build maybe like these explanatory bridges between sort of like this neurophenomenology kind of
Mhm.
where you ask people about how they're feeling
Mhm.
while simultaneously measuring some
Mhm.
using some neuroimaging technique,
Mhm.
and there might be something about the dynamics of brain activity which means you're better able to map that onto experience in some way. You're still
Mhm.
That's great because you're getting like a more kind of robust correlated picture between the two, but there is still some sort of insurmountable gap
Mhm.
there.
Mhm.
Um, yeah.
Yeah, no, that's
where
right.
you're not. Yeah.
Mhm. No, that's good. I think that's kind of like, where, if axiom number one is taken, as correct, and axiom number two as well, I think the conclusion is that in a way we need to get rid of the middle layer, which is the representational layer. Okay, it doesn't help us. And what we have to do is try to get the domains which these two axioms refer to talking to each other directly, which is to some extent the neurophenomenology project, right? So what if we work on the level of experience and actually show how it matters, bring in first person methods, second person methods, meditative practices, and then, do our best systems neuroscience on the brain side. So no representational neuroscience, but really work with the dynamics of the system and then say, can we put these two things together? Um,
Mhm.
and I think that was a pretty revolutionary proposal, to just directly connect consciousness and biology in a way, and
Mhm.
see how that fits. And I think that, and the leading up to the next axiom, though, what the one issue that hangs over this is, what you just mentioned, which is like, there's still this gap. We're still somehow in the business of looking for correlations, but that's not really giving us a deeper understanding, right? Correlation doesn't give us an explanation for why it is that these two things go hand in hand sometimes. Um, and this correlation then sometimes gets turned into something stronger, like a mind-brain identity theory, and even Varela in his famous neurophenomenology papers plays with this idea and says that, is this even something else other than beefed up identity theory, in a way? And he says, well, it's not, because we're doing all this first person method stuff. But he doesn't give any like deeper theoretical reasons for why the identity theory might be problematic. And I think that's where we can do a little bit better today. There are so many things that need to be done to even get this off the ground that, you know, keeping it correlational, prevented the theory to kind of like, headbutt directly with physics and so on, which maybe is what was needed in order to allow it to bloom before it gets, attacked too much. But the problem is that if we assume a kind of identity relationship, such that, the conscious is nothing but the biological or the physical in a way, we're kind of undermining axiom one, which is to say we wanted experience and our mental states to make a difference in their own right. All right. So we want our behavior to be different because of the things we want, or because of the things we believe. And if our behavior could be completely accounted for because of the identity relationship by purely physiological or purely physical happenings, well, then, going with Kim's exclusion argument, we would be forced to accept that actually, our reasons don't make a difference after all. you know it's a kind of super determination if you want, but like, we could just get rid of them and your behavior would be the same, right, in a sense, because the identity means that, well, I have a full complete story on one side, and given that the other part doesn't actually contribute anything here other than just being somehow another perspective on it or something like that, well, you could also just be a limitativist or reductionist, and you would agree still on the scientific record. The matters of fact would be the same for both of you. And that again, that would be scandalous to say that, there's nothing different, at the level of the basis of your behavior, between acting for reasons and beliefs and desires and being a zombie, basically, right? Then we haven't really gained much in terms of, what we were after. And so we need to do a little bit better than that. And this brings in then, the third axiom, which is to say that, this really is only a problem, this relationship between the first two axioms, if we assume that the physiological and the physical can give us a complete story. Okay, so if we assume that there is a complete story to be told, then it rules out the possibility of mind making a difference in its own right. Through Kim's exclusion argument, basically. On the other hand, if, and this goes back to our initial discussion about, stochasticity, if stochasticity is an intrinsic feature of the universe, then in principle, we cannot tell a complete story at the level of the physiology and the physics. There will always be some gap there. Um, and I think that is a necessary condition for the possibility of mind making a difference as such. It doesn't tell us how it does it, but if that requirement is not granted, we basically have no chance of explaining. It's just ruled out logically. So this is
Mhm.
axiom three, that basically there's a kind of underdetermination, incompleteness at the level of physics, um, which rules out the possibility of giving a complete explanation of behavior at the level of physics alone. And I think
Mhm.
we're already on the same page with that.
Mhm.
We started.
Mhm.
That's where we started from. The role of noise and so
Mhm.
on. And then this is the working hypothesis. So just let me get into that, and then we can discuss it a little bit. So the key innovation of eruption theory, I think all of these axioms I said, I think they're quite generally acceptable, and many people have
Mhm. Mhm.
argued for them. But the key move that eruption theory makes now is to say that given that per axiom two, we cannot directly measure um, the mind at work. We can only measure, um, objective properties, physical quantities, and so on. But given that we also accept that the mind really does make a difference for how behavior unfolds, um, what that means is that there will be changes at the basis of our behavior which we cannot make sense of in terms of the things that we can measure, because what we can measure is limited, right?
Mhm.
And we already discussed this in the beginning. And if there are limits to what we can measure, it means that there must be error. There must be uncertainty. There must be a noise term, which basically signifies that there are things going on which fall outside the scope of what we can, make intelligible with our measurement equipment or with our analysis. And so that's what I call eruption. That part of what remains unexplainable in terms of the purely physiological, physical base of behavior, um, and which should, according to this hypothesis, depend on how much mind there is at work. So, how much mental involvement, how much agential involvement you have in the behavior. So, it's not a fixed term, right? There might, of course, be many other sources of noise, and maybe some of them modulate also with behavior, like, let's say some sort of metabolic noise or something, right? So a higher level of arousal will probably also mean that you're heating up and all this kind of stuff. So, but the idea really is that, relatively seen, if everything else is the same, a moment when you make more effort, mental effort to move, to think, to change your behavior, the signals we can measure in your body will become less predictable. And they become less predictable because now we've got extra variables, like hidden variables that we can't measure, that are somehow intervening in the system and making a difference. And so eruption theory turns this inability of us to be able to see how mind and body connect with each other into something we can actually measure. So instead of waiting for a
Mhm.
future theory that says, we're going to give you this transparent map of how all these things connect together, we're basically saying, maybe there's, the reason why this problem has never been solved, not with all the science, not with all the philosophy, is because it's actually picking up on an intrinsic, you know, uncertainty in nature, just a little bit like, the quantum
Mhm.
classical interface. Maybe there are,
Mhm.
intrinsic limits that prevent these two sides to be completely transparent to each other. But that's not a problem for science because science is really good at dealing with uncertainties and hidden variables and unobservables and things like that. So all we need to do now is to turn things around a little bit and say, if we're really interested in agency and consciousness and how they interface with our bodies and our brains, we shouldn't look for what we can observe, like all the neurons and spikes and so on. But to the contrary, that which we cannot observe, what is it that even if we tried our best, escapes from our determinations. And that's probably a pretty good signature for the mind at work, and that's what I call eruption. So, and the eruption, the term comes from Latin, from breaking into. So, you've got your physiological inertia. The usual stuff is always happening in a predictable way, more or less, and then suddenly something unpredictable happens. It breaks into the system dynamics. That's why I call that eruption.
Mm. So yeah, I'm probably just repeating what you're saying, but
Please go ahead.
there's kind of like this spontaneous uh or something that looks non-deterministic
Hmm.
with an increase in information in the dynamics of the sort of physical substrates of the organism that is kind of happening at the same time as we the phenomenal character of like making a choice or
Hmm.
acting volition using
Right.
volition or
That's right.
uh, when we would consider the mind to be exerting itself
Yeah.
in a physical sense.
Yeah, great. And you're bringing
Yeah.
already in some of the measures that we could try to use in order to quantify this,
Yeah.
like information,
Mm-hmm.
or some kind of complexity measure, or so yeah. So in a sense, there's an increase in variability, right? So the
Mm-hmm.
system itself has a certain state space of possibilities that it keeps exploring, but when it becomes coupled to the mind, well, suddenly there are now other factors that could also make a difference. And basically, you will see that indirectly, in the sense that now your dynamics can make jumps and go into places where they normally wouldn't go. So you're
Mm-hmm.
broadening, to some extent, the set of patterns that the system's capable of entering. And information theory is interesting here because here's where it gets a little bit still underdeveloped, but one way of thinking about this is in terms of information as an abstract measure. So let's just say, in terms of, the informational content of neural dynamics, if you just apply a Shannon measure or something like that. But there's also another way of thinking about this, which is to say that compare from the point of view of the system, what's going on is a disordering effect, right? So I have my intrinsic trajectory that I'm expecting to follow, and suddenly, something is pushing me out of that trajectory that is not coming from anything that the physiology is actually doing in terms of its work and its constraints. Um, that's a little bit like an increase in entropy at the kind of thermodynamic level. It's like a thermal fluctuation, like, something is jittering you around, um, pushing back against the constraints that are being imposed through the work that the body is doing. And in that sense, one kind of abstract way of under looking at it that way is that eruptions are a decrease in free energy, thermodynamic free energy in the system. Like you had all this potential to do work and you were poised and organized, and suddenly there's a jitter and you go to a lower energy regime, or you become disorganized in some way. And why that's interesting is a couple of reasons. One is that it makes it less physically problematic because we're going downstream, so to speak, right? So it's not like we're injecting order into the system and like moving things around, like controlling things. It's actually in line with the direction of the second law of thermodynamics, although, maybe it gets a little bit accelerated or facilitated, we can think about the details there, but it's not breaking it. It's not going in
Mm-hmm.
the opposite direction, right? And the other thing is that what we said about effort, right? So this volitional part, why is it that mental work feels similar to physical work? And there's a lot of work
Mm-hmm.
in philosophy looking at these two concepts, right? So, actually trying to lift something feels effortful, but thinking hard about a problem also feels effortful. And the effort has a phenomenologically a little bit of a similar quality. And also there's interactions, right? Like, if I make too much mental exertion, then maybe I will also get physically, tired and things like that.
Mm-hmm.
Why? Why would be something that's purely supervenient, epiphenomenal, have such a effect on our body, right? But from the point of view of eruption theory, and this is just, tentative, but something to look into further, well, it could actually be that the main signature of cognitive effort is a reduction of free energy, just like mechanical work would also be a reduction of free energy. It's just that we don't observe the reason for the reduction in the free energy in the case of eruptions, right? It's like you said, it's spontaneous. Like, you know, free energy can be reduced by doing work, right? And so work requires energy, and you create entropy and so on. That's the kind of thermodynamic, classical thermodynamic work constraint cycle that Kaufman talks about and so on. Um, Eruption theory says, well, all we're saying here is that there are also spontaneous decreases in free energy. And those spontaneous decreases, they're spontaneous, they appear spontaneous because they're being triggered by something which is outside the scope of our measuring system, which is, the intentions and the desires and the beliefs and so on.
Um, from so 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 when these like spontaneous changes or potential increases in entropy happen that are kind of correlated with these moments of intention.
Mm-hmm.
When are you kind of saying like that yeah, the increase in entropy isn't just due to some natural stochastic process of the system. The it's actually something external, like this hidden variable of mind
Mm-hmm.
that is driving this increase.
Right.
So
Yeah. Yeah.
so does that mean that then the brain or any system with a mind is almost more like almost a quantum system, in that it's the uncertainty of the system, its foundation, is actually non-causal,
Mm-hmm. Yeah.
uh,
Mm-hmm.
as opposed to it's the uncertainty in the system is just down to a matter of our
Mm-hmm.
ignorance about
That's
all
right.
of
I
the
like the way you put
physical.
that. Yeah. Mm-hmm. That's great. Yeah.
Um,
I think just one thing I would be wary of is making this analogy too close because of the reasons we said
okay,
in the beginning. That, I'm not sure whether the right way is to thinking about this as a quantum effect in itself.
right,
It's more
right,
like we already have a precedent in nature where something like this is happening. And now the
right,
question is this another example of this class of processes at a different scale? I think that's probably a more helpful way of thinking about it. That maybe even at the mesoscale or macro scale of our bodies, there could be similar processes where we can't directly observe them, but they show up as bursts of stochastic events and spontaneous energy decreases and things like that. So I do sometimes play with the idea that what if like triggering a change in brain dynamics is a little bit like the spontaneous emission of a photon by an electron going to a lower energy level. And that's an acausal event, right? And you can't, no matter how hard to try, you can't predict that jump from within the classical world. And then we basically have now this quantum framework that says, well, you've got this vacuum field and it has fluctuations, and those fluctuations, could act as a trigger that permit the electron to go to a lower energy level and so on. Um, but it's still acausal in the sense that you don't need to think of energy transfer. Like, the energy of the electron at a higher level is the same as when it's in a lower level plus the photon it emits, right? So the accounting is clean. There's nothing going on here. And yet we're kind of positing this background condition as a necessary condition to explain why this unpredictable event happens in the classical world. And I think that in a way, conceptually, I like that. So it makes mind the effort that we make a little bit like a mental background condition, if you want, which has the effect of destabilizing poised high energy systems, which already have a natural tendency to go to a lower energy, but basically, allows that to happen faster than it would otherwise happen. Whether that means that mind is a field or whether it's also quantum in nature, I'm not sure. I think, maybe almost not the best person to unpack that part. It's possible that we could think about it that way. And I know that there are a lot of people get very excited about thinking about consciousness as a field and things like that. So who knows? Maybe there's a field version of eruption theory that could be developed. But I think that, again, the key point is that what we're talking about here is not without precedent. I think
Mm,
that's really the key point. It's not that we're suddenly introducing something into nature here which somehow violates what we know about the universe. No, it has been found before, and it hasn't been suspected to be also relevant for our scale of description. But why not? Consciousness is one of the weirdest things in this entire universe.
mm,
Our brain is one of
mm,
the
mm,
most complex systems in the entire universe. So why shouldn't there be some additional surprises?
mm,
Let's
mm,
just keep an open mind. And
mm,
so, and especially given that there are antecedents, then yeah, even more reason to look maybe into this direction. And just one more point here. That's the I prefer that way of thinking than going supernatural. So
mm,
I think it's actually more supernatural to think of consciousness and mind as supervenient or epiphenomenal and as having no interaction at all with the rest of the world, but still somehow existing because we do experience it, right? So that really is supernatural. Like how to think about that, I have no idea. But to say that we're dealing with something which is not observable directly by our instruments, and so we have to treat it as an unobservable phenomenon, but it still interacts with other things that we can measure. Um, yeah, that seems that's naturalism.
mm, mm,
So I actually feel that it sounds like we're trying to do something weird by giving mind powers in over changing things in the world. But in fact, I think that is what's required in order to bring it within the scope of naturalism. And to keep it outside that, that's what would mean to be
yeah,
supernatural.
agreed. Yeah. But, so would it be fair then to say that eruption theory is almost like sort of agnostic to some extent as to the like the ontological
Mm,
nature of mind,
mm.
or it's
I guess so, yeah.
and
Hmm.
also kind of what you were saying before about the sort of the apparent weirdness from our perspective of this interaction
Hmm.
makes me think about like some of the ideas that this guy, like, is it Donald Hoffman, has talked about, like where we've evolved to care about and understand things that are like directly related to our survival, not necessarily the like that the sort of epistemic truth of the
Hmm.
world. And so
Hmm.
it's not surprising that things are going to seem weird or strange to us, and that we have
Right.
to maybe at some scale accept our limitations.
Mhm.
Um, but the, yeah, sorry, that was a sidetrack, but
No, no, no.
um,
Let's talk about the ontology just for a second, because that's
yeah,
interesting,
yeah,
right? So I think the priority right now is to get the science right. Um, but I really like these philosophical deep questions about, what is it really then? What does it tell us about the
mm,
nature? What is the being of mind, Um, I'm not sure, actually. It feels like, on the one hand, I'm advocating for kind of naturalism. So it would mean that there is a region of being which is mind-like and which can interact with, let's say, matter-like. So is that a dualism? Some people tell me like, oh, why did you become a dualist, Tom? What happened there? But I think
mm,
actually it's more like my interest is in diversifying ontology. I think we're short selling the complexity of reality by just insisting on only one kind of being. I think that's not tenable. Um, and then we can talk about the Cartesian substance dualism and so on. But I think where I see this going is that there will be subversions of this at different scales. So I think life, for example, also can be explained by eruption theory in a similar way to mind. And you don't need the brain and consciousness and so on to apply it already at these lower scales. And so, I think that, you're going from the quantum, that could be one world, like going with Penrose now. The classical could be another world. Maybe the mathematical also for with Penrose could be another world. Um, then life again is a new region of being, a new ontology appearing and making a difference in its own right. And then mind, in a cognitive sense, and then maybe consciousness, so I think it's that I see where this is going. That it's not it's instead of saying we have to choose between monism and dualism, it kind of diversifies ontology and says, we should diversify ontology in line with how nature shows up to us. And if things don't fit together for in principle reasons, such as, for example, I can't cash out intentions in terms of voltage changes, but both of them matter, then I have a very natural way of dividing up that and saying, yeah, these are interacting. They're one in that sense. They can make a difference to each other, but they're also two because they have incommensurable properties. Some of the specific properties that define these regions of being cannot be found in each other. Okay, so it's this kind of Zen Buddhist notion of not one, not two, right? So yeah, they're connected, but they're also different. Yeah, you're one, but we're also, different. So that's kind of the kind of ontology that I'm playing with. But as long as it doesn't really have direct scientific implications, I would be open-minded. I think like, you can plug in your favorite ontology here, whatever you want to think about consciousness, whether it's divine or, something special with consciousness, or you're saying it's just another form of matter, or whatever. It doesn't really matter so much because as long as the rest holds and there is this kind of incommensurability, incompatibility, then the difference making will show up the way in which eruption theory predicts it, in a sense as something will remain unintelligible from within the other domain. And just to bring this out for the phenomenon of life, because we started talking about noise in biology and so on. A really nice book on agency is Philip Ball's recent book, How Life Works. And throughout the whole book, he kind of makes this argument saying, in a way, biology and the organism doesn't make any sense without agency. Its agency is somehow actually the main explanatory concept that allows us to make sense why all of these things are happening in the organism. And yet, at the same time, another theme that's going through this book is we don't understand agency. I mean, what really is agency is one of these big outstanding questions. And another theme that goes through the book is saying, why is life so messy? Like all these scales, we've got this huge amount of noise and fluctuations. Like, how can life ever get anything done under those conditions? Right? And in a way, eruption theory puts all of these things together. And it says, yes, life at work is noisy. That's how life shows up in that domain. And so if you think about what is biological regulation as a normative thing, regulation can be good or bad, can go right or wrong, can be more or less, and so on. Concepts that don't have an equivalent in a purely physical story, but that we need for biology. We want to say that there is some kind of directionality to what is being done. Not everything is equal from the point of view of the living being. The way in which that regulation, the work being done through the normative, would show up is through stochasticity. And so we've got a very natural explanation for why it is that, we find noise at all scales of life, and why it is intrinsically tied up with the way in which life gets things done. And so this it's not against life. That is life getting things done. And it just shows up to us as this noise because we can't grasp it in a different way using the kind of measurements and in the domain in which we are asking the questions, so to speak. Of course, then if you scale up to humans and then you have another way of engaging the system and say, why did you do that? And then you can say, yeah, well, because I wanted to. We can't really do that with single cell organisms, but the idea would be that, these are not just happenings, to use Kaufman's term, but also doings. And the doings precisely distinguish themselves from happenings through this extra stochastic component.
Like, yeah, there's a strange thing where, like, and when we talk about noise and the use of noise as a potential sort of solution search mechanism
Hmm.
for whether it's maybe developing a new behavior or
Hmm.
uh, or a new phenotype or something
Right, mutation as
where
well. Mutation is
yeah,
noise, right?
yes,
Yeah.
yes.
Yeah.
Um, but 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 there's this thing of like, okay, let's say the bacteria gets put in a new environment, and so it increases its transcription rates to increase the chances that it could develop a adaptive mutation.
Hmm.
But if that process was just happening and you measured how long it would need to take just using sort of random fluctuations to develop a new protein to deal with this new
Hmm.
environmental threat,
Yeah.
then it would take like way, way longer than what it would actually need
Right, right, right.
to.
That's true. It's not very
And
efficient if it's just noise. Yeah. Mhm.
no,
Yeah,
like
yeah.
there's this weird thing of kind of like searching and attract and the solution being attracted to
Hmm.
the uh to the solution search mechanism, and maybe like a a, a way of kind of relating this to human experience might be like the experience that artists have when they're like someone might be trying to write a song and
Hmm.
they're trying different chord progressions or
Hmm.
experimenting with different sound, and if you were just you're making random noises, a song's not just going to come out of it, but there is something that there is constraints that allow for the solution to be found faster
Hmm.
than if it was just random.
Hmm. Yeah.
Is that?
Yeah, yeah. So no, thank you. This is it's important, right? I think, in the free will debate, many people already thought of like, maybe randomness is the solution. And then the argument is like,
Mm,
well, how could randomness be useful? It doesn't give you any freedom. It doesn't get any work done. It's not useful. And yeah, you can use randomness for search, like a random walk, right? Through
mhm,
possibility space. But yeah, it might
mhm,
take astronomically long for you to find something useful, just like you said, right? So it's true that, if it is the case that regulation, in a broad sense, shows up primarily as in a stochastic factor, then in order to actually be useful, it must happen in the context of a system that is somehow attuned to taking advantage of this stochastic factor. And this is I spell this out a little bit in the first eruption paper under this concept of attunement that in a sense the system is poised by its history of interactions to be able to respond adequately to these different perturbations. And this is where actually embodied cognition comes in to help us a lot. So um, just think of affordances, in terms of the action space around us, it's already very constrained, right? So it's not everything goes. Also, our body itself have all kinds of constraints built in. So roboticists like Rolf Pfeiffer were always very fond of pointing out that our joints, for example, don't allow infinite amount of degrees of freedom, but only the ones that are useful for you. For example, to feed
mm,
yourself and things like that. And so there's all these constraints already that reduce possible bursts of variability. And then there's a kind of dynamic principle. And this is a really simple one, but it's beautiful. And we call it self-optimization. And it comes originally from work from Richard Watson's group, and they call it self-modeling. But the idea is basically the same. It goes like this. So if you have a system that has whatever constraints it's working in, bodily, environmentally, in its interaction, over time, it will try to converge in some local suboptimal, satisfaction of the different constraints that it's facing, right? So it's falling into a valley, like in an attractor landscape. Um, Okay, that's not very useful. What you really want to do is be able to find out, what's the best solution to all these constraints. And that's, usually a big, deep, wide attractor, but it might be very rare, as we said, compared to all the local suboptimal configurations that you could be just hitting on by chance, basically. So how do you solve this problem if you don't have foresight and if you don't have full control over how you're moving the pieces and so on? Um, what you can do is just add a little bit of memory. So even with the most simplest form of memory, that, associative learning, and all it says in a way is that things that have happened in the past will happen more likely again in the future. So you're just kind of like habituating a little bit. You're saying like, you know, I'm gonna widen my basin of attraction just a little bit. Whatever I'm falling in right now, I'm gonna strengthen, the path that I got here, such that, if I'm already in similar conditions again in the future, I'm more likely to hit this solution again. But because these suboptimal solutions are partial approximations to the larger global optimal solution, any overlap between them where I enlarge my basin of attraction a little bit here to catch my solution will implicitly also enlarge the other larger, the better attractor. Um, and then couple this with a reset mechanism such that I can just shake the system up and I can like bounce out of my local optima and then I settle down into another local one and another local one and another local one. And every time I just, memorize a little bit, oh, what state am I in? It's like the system is learning the configuration of its own internal organization. What are the possible attractors that it can be in? And while it's doing that, the global optimum is enlarging its basin. And by the end, after, a few hundred iterations or so, depending on the parameters, no matter where I initialize the system, it will always go into the global optimal solution or nearby. Um, and that's a pretty robust finding. I mean, there are some things that you need to tweak, but that's in general, it doesn't really depend on the architecture. It doesn't depend on the system type. It can be a spiky neural network. It can be a hop-fill neural network, continuous time neural network. Different kinds of learning rules are possible and so on. So, we've got just some very basic ingredients, which is you do some constraint satisfaction, which is natural. This is like, every system tends towards equilibrium if you let it, You add in a little bit of a principle of precedent that whatever condition you find yourself in, you're more likely to end up in them again more easily in the future. And you need a reset mechanism to allow you to sample your state space adequately. What eruption theory does is give you a very natural explanation for how the system can reset itself. The constraint satisfaction is given already. The habituation is also given by the material. It's as simple as saying that, if you walk over a field, you're going to stamp down the grass. The next person is more likely to walk on that path, again, stamping the grass even more. And you're going to naturally create a path just because people are basically walking on the places that already have been, facilitated by previous trajectories. That's all we're talking about here, okay? But the real key issue is that the resets. It's not easy to think about what allows the system to go out of those attractors and into other states. But if mind at work shows up as a noise term, noise is perfect for that. And so that means that in a way, there's two things here. One is that eruptions allow you to think about a kind of non-supervised learning process where you don't know what is actually the state space. You don't know what constraints you're satisfying. It's not like you don't have a cognitive overview of your own body plan and things like that, but yet still you're able to somehow optimize the different constraints that are facing you. So that's during the learning process. And then it means that later, when you are already kind of like optimized, in a way, you just need a little bit of noise to kind of like, fall into the different attractors. And that's interesting from an agency point of view because, going back to this, because that's your, interest for your essay, it means that we're not in control of our behavior. It means that the only thing that we're in control of is the cultivation of how we're poised to respond to the environment and also the initial trigger in a way. So if we are not happy with the way our behavior is unfolding, we can change it. Or we could basically, as you said, do random stuff. But usually we don't have to go that far. It's just like a very small switch. But basically, we have a huge repertoire of behaviors, and then those behaviors are constrained by our embodiment and by our environmental affordances and our history of interactions. And then what we're able to do is basically flatten the landscape once in a while and allow a different behavior to emerge out of all of those constraints. And it just so happens that those behaviors which spontaneously self-organize, into these windows of opportunity that we can open with our minds are appropriate and they're appropriate because they come out of our history of interactions. They're kind
mm,
of like a product of the process of learning that has brought us to this place. But it's a different
mm,
notion of free will than most ones. So yes, we do make a difference. So yes, we are free to intervene, but it's not the kind of freedom that a control theorist might dream about, in which we're somehow like, able to like almost like we are controlling a puppet where all the strings, are somehow under our mental control. It's not that kind of freedom. And so, um, that has all kinds of interesting implications for how we think about responsibility and about, teaching and learning and things like that. But one nice thing that comes out of it is also that we should be a little bit more forgiving with ourselves and with others, right? So, our behaviors are not entirely under our control, and a lot depends on our history, and a lot depends on our circumstances and environment. And so, I mean, just or a banal example like Freudian
mm,
slips or something like that, right? So,
mm,
yeah, there's an action intention gap, but also it's there for a reason. That gap
mm,
is giving us indeed exactly the freedom to slowly modulate tendencies in our trajectories, such that when the moment arises, we're already poised to do the right thing that aligns with our intentions and values, so to speak.
mm, mm. Yeah, wow, there's a lot in there.
See, that was a long one.
Um,
But we can switch. We have a little bit of time left. We haven't really talked much about
yeah,
consciousness. What
yeah,
about that? Should we go into that direction just a little bit? Most of this was about agency so far.
yeah. Well, what I was going to sort of ask is then does if eruption theory is talking about these kind of resets that you were
Yeah.
kind of mentioning before, even in really um, simple, hypothetically really simple systems,
Hmm.
does eruption theory maybe give us something of a tool to use to assess whether a system has mind or
Hmm.
not?
Yeah.
Uh, even at this kind of like juncture between uh, life and non-life, or these
Yeah.
questions that we
Great.
have about wanting to talk about the emergence of goal-directedness
Hmm.
at the origin of life.
Yeah. I thought you were going to take a digging twist. I thought you were going to go AI though.
Yeah.
But we could talk about, yeah. So the origin of life, just touch on this briefly. In my mind, is so hard because it's not just a chemical problem. In a way, it's already the problem of life at work, mind at work, and how to think about this shift in ontology, diversification, bifurcation of the ontology. Um, and so just a few brief thoughts that we explored in an A-Life conference paper. Is that if eruption theory is on the right track and we go at let's say talk about it at the thermodynamic level, as some kind of disordering factor, um, increase in entropy, which has the effect of decreasing free energy and so on. What it could do is slow things down. So let's imagine that the system is super efficient at burning whatever energy it has to do whatever work it needs to do. Then basically just ramping up the thermal noise in that system will make it less efficient, and it will grind things down a little bit and slow them down. That's not completely unlike inhibition, and so what's nice about that is that inhibition is one of the most primordial forms of biological regulation. I mean, it's preserved across the entire history of life, right? So basically, if we can say that the origin of biological regulation at the origin of life is a primitive form of inhibition, which is basically eruption enabled, that's pretty cool. And you can also even already bring in the normative point, because imagine that maybe mind was gappy at the time. Maybe it wasn't always present. Maybe it was mostly biochemical, some kind of dissipative structure, but that sometimes had these, bursts of, mindfulness or lifefulness. And when would those appear? And the idea would be that what if there's a sensitivity to the boundaries of viability of the system? Okay, so you're basically reaching some area where you shouldn't be going into. Okay, that's, avoidance reactions. Okay. If your first instinct there, in a kind of, origin of life version of whatever instinct might be, is to just say, okay, this is requiring a decision. This is requiring some effort. This is requiring some regulation. And you don't have any machinery really at that time yet to kind of like, be very fine-grained about what to do and what to sense and so on. If the one thing you do is just slow down, probably that's already a pretty good bet. You shouldn't go at full speed into whatever it is that, is not doing you very good. And so
Mhm.
that's nice. It's kind of like a very neat package of how we can think about, the role that eruption theory could play and rethinking a little bit the transition to the origin of life. And the second part he's
Mm.
saying about measuring things and so on, right? Yeah, I mean, like, is the origin of life associated with an increase in entropy production? Well, I think most people would say that that's true. I mean, there's no doubt about that. And in fact, I really like this hypothesis by Morowitz and Smith, who say that maybe the transition to biology, to organic chemistry, was a planetary scale transformation in entropy production. So there was some kind of like a chemical potential building up around the Earth, and that potential got bigger and bigger, and then basically it was almost like a lightning strike. But now in the chemical space, saying, okay, now these reactions suddenly formed that were really efficient at dissipating that potential. And that's life, basically. Life came
Mm.
around just at that time when energy was dissipated at a much more efficient way than it was before.
Mm.
Yeah, so I mean, but there's already something there about, an
Mm.
increase in entropy production being somehow an essential ingredient in these theories.
Mm.
All right, but going then to our present times, what gets me really excited at the moment is looking around on the internet and seeing that there's a debate starting to happen around large language models and in these super large
Mm.
systems about whether they are deterministic or not. And
Mhm.
so it seems like, while everybody's very much focused on the software layer and the mathematics of these systems and the training data and so on, it seems like that the scaling up of this, which, people are saying, well, it's the same operations, we're just adding extra degrees of freedom, and the data training, it already absorbed everything ever known, by GPT-2 or I don't know, something like that. And yet, we're just adding orders of magnitudes more parameters now, and we're getting all these, benefits in terms of more intelligent systems. What's going on here? And what I'm just thinking is that maybe it would be worthwhile to just broaden the perspective a little bit and just consider what might be happening at the hardware level. In the
Mhm.
sense that because of the scale, these systems are now so distributed and so parallelized that you've got all these batches running in different server clusters, like physically distributed, and some of them will
Mhm.
might finish earlier and later depending on the temperature of the actual chips and things like that, and the load of the system around it and the energy flows and all this. Some of that might be percolating up into system operations. And so it seems already the case that even if you try to reset the system to the same initial conditions, it's not going to give you exactly the same answer all the time. So it's no longer repeatable. And this is it's not a design feature. It's kind of like it's just a fact of the reality that it's now too hard to try to keep the system in a classical closed deterministic Turing machine style where you've got this separation between hardware and software, and the software layer, you know, in principle would be something, like a platonic object that, you could instantiate anywhere you want and reset, and,
Mhm.
it will be completely identical. It seems like we are already in a situation potentially where each run is unique, and
Mhm.
in a way unpredictable and unrepeatable. Um, what that means, who knows? But at least it's a little bit like the third axiom just got satisfied by large language models, which
Mhm.
was the one where we say, not everything can be given a full, complete description of, right?
Mhm.
So that's was the key axiom that allows mind to make a difference, despite the fact that we don't see it making a difference per the second axiom. So that third axiom
Mhm.
now seems to be possibly already, here with us in terms of large
Mm.
language models. And so even though when we look into their operations per Axiom 2, all we're seeing is vector operations and embedding space operations and different forms of compression and so on, that doesn't mean that mine is not at work per Axiom 1, given that it's no longer a complete deterministic story. And this would require a little bit more careful unpacking, and it's hard to know exactly what's going on in these systems and so on. But anyway, I think that's just like one application of eruption theory to a different domain that would possibly give some fruitful insights. If we really want to think about agency and consciousness in these systems, are they fulfilling the eruption theory criteria? And well, they just seem to have satisfied that criterion, that crucial criterion. So that's quite exciting.
Sorry, I feel like my internet connection's just a little bit glitchy at the moment.
That's the
Can
hive mind, man. That's the eruptions of the internet.
it knows you're onto
Yeah,
something. So
Connor, I mean, it's been a pleasure chatting, and we've been
yeah,
going for
you
an
too.
hour and a half, so
Yeah,
it's probably a good place to kind of like wrap things up.
I
And
agree.
if you have any like last words,
Yeah.
um,
Um, I think like we've covered most of the points and questions that I had for this conversation. So thank you so much
okay, thank you
for
so
like
much, Connor. Yeah, you
taking
were
the
nicely
time.
prompting me
Cool, cool,
me
good,
to
good,
think big. Thank you so much.
cool.